Welcome to the Bielik method, where today we are talking about another exponent rule called the power rule. Okay, the power rule is one of the rules that you will need to know when dealing with problems such as this one behind me right here. You'll also need to know what happens when you have a negative exponent. And hopefully you're watching my videos learning the basic rules. This one I'm going to go through the basics here, get into something a little more complex. Hopefully you already have watched the video on negative exponents so you understand what those do, and then move on to a problem such as this, which was given today as homework for my students, and I already know that there's going to be some questions behind it. So first and foremost, what is the power rule? Power rule means you have a power over another power, so one exponent on top of another. So here I have a to the m power all to the power of n. So I have two exponents, one on top of another. Now the rule is as simple as this. This is going to come out to a to the m times n. You multiply the exponents. So you just take m times n and you get your result. Now let's look at it when we're actually dealing with some numbers. So here we have nothing but variables. It shows how the rule works. Now I have 3 to the 4th power all to the power of 3. So what does this really mean? I'm going to write this down underneath what it's actually saying so you understand the why behind it. 3 to the 4th power is 3 times 3 times 3 times 3, 4 times. But then we're taking that information, 3 to the 4th, and they want us to do it 3 more times. So we're going to say times 3 times 3 times 3 times 3. And we're going to do it one more time, 3 times 3 times 3 times 3. And we have a grand total of, okay, count them up, 4, 8, 12 threes. So the answer here is really 3 to the 12th. How did we get it? We just multiplied that 4 times that 3. Because knowing the power rule, it tells us just to multiply our exponents. So we have a 4, we have a 3, we multiply those out, and we get a 12. All right. Go down here. Now this is something you need to understand. When you have two parts on the inside, you have to distribute that exponent that's outside of the parentheses to both parts. There's an imaginary, not an imaginary, I always say that. There's an invisible 1 right up here. We just don't show it. So that's saying 3 times 1 and 3 times 5. So if I were to show why this comes out to what it is, I'd show the steps. 2 times, or to the power of 1 times 3. And x to the 5th times 3. You're just going to multiply those exponents out. And our grand total here, if we were to simplify this, is 2 to the 3rd power x to the 15th power. Now, on a problem like this up here, 3 to the 12th is a very, very large number. I'm not going to sit down and calculate 3 times 3 is 9 times another 9. You could. That's a pain in the rear end. I'm not going to spend my time doing that. I'm just going to punch into my calculator 3 to the 12th power, and I'll get my result. Here, 2 to the 3rd power, however, you could probably calculate that on your own. 2 to the 3rd power just means 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. So our answer is 8x to the 15th power. And that would be this simplified all the way down. Okay, so here's our basics. Multiply your exponents when you have one power over another power. 4 times 3 is 12. 5 times 3 is 15. There's an imaginary 1. 1 times 3 would give me 3. All right, so now let's work out one of these more complex problems. I'm going to erase this information and just give the answers. I want those answers still to be up there so that you can see them. That way you can kind of connect what it is we're doing. So real quick, 3 to 4 times 3. Again, I don't have it in front of me, but I can solve it real fast just by multiplying those exponents. This is going to be 2 to the 3rd, x to the 15th. All right, so now you have your answers off to the side. You understand the why behind it, hopefully. Let's go to this problem. I have an exponent on the outside of parentheses, which means that it needs to be distributed to all parts. It needs to go to that 2, it needs to go to the m, it needs to go to the 3, and it needs to go to this n. So I want my students to take the time and just write it out now with a negative exponent. This is a very important step for you to take. A lot of kids will want to skip this step and just move on to the next one, and it's going to create havoc. So just take the time, say 2 to the negative third. Write it out, 2 to the negative third, m to the negative third, m to the negative third, over 3 to the negative third, and n to the negative third. Hopefully you've understood now and what I've done, and I'm just simply distributing that exponent to each part. All right? Now, I have negative exponents throughout this entire thing. It's important for you to understand that if I have a negative exponent, I need to turn it into a positive exponent. And the only way to do that is by changing where it is on a fraction. So if it is in the numerator, these need to move down to the bottom. Both the 2 and the m need to move down to the bottom, and that will turn them into positive exponents. Here in the denominator, I have negatives as well. The only way to turn them into positives is by moving them to the top. So the last and final step, well, I should not have said that. It is not quite the last and final step, but second to last and final step. 2 to the negative third becomes 2 to the positive third, but it moves to the bottom. M to the negative third becomes m to the positive third, but again moves to the bottom. This is now on the bottom of the fraction. This is moving to the top of the fraction. And I am almost done. The last and final step that I have to do on this problem is change 3 to the third power into a number and 2 to the third power into a number. Now you can pull your calculator out and type in 3 to the third, and it's going to give you 27. Or you can mentally think that through. 3 to the third power means 3 times 3 times 3. And we know 3 times 3 is 9. 9 times 3 is 27. So I'm going to get 27 into the third over 2 to the third power, which is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 m to the third. We now have our simplified expression going from the top to the bottom. Now we get into something a little bit more complex here, and I'm going to put one thing in here just to make it more of a power rule problem. If I were to add a 4 above the m, that's going to change things. And if I put a 2 above this n, that's going to change things. Instead of just distributing and having a 3 and a 3 there, I'm going to need to use my power rule and multiply it by both the 4 and the 2. So let's jump into this and make sure it makes sense. I'm going to break this into parts. I'm going to look at 1, 2, 3, 4 parts. Let's color them up so you can see them. Focus on negative 3 is just negative 3. That's all you need to deal with. Then I want you to focus on k to the negative third power and only focus on k to the negative third power. Then I want you to really look at this as all one part for you to figure out and solve. You need to figure out what this is going to change into. And then last but not least, what's the color I haven't used? Yellow. Okay. Figure out what that's going to turn into. Oftentimes kids look at this problem, they freak out. I totally understand why. There's a lot going on. It's intimidating. That's a problem that kind of like stares you in the face and is like, yeah, see if you can solve me. Well, you can do it. Okay, break it into parts and just ask yourself, how do I simplify this part? How do I simplify that part? So starting with just negative 3, only focus on the part that's written up there with the green underline. Negative 3 simplified is nothing needs to be done. You get a negative 3. It was on top of the fraction. It's going to stay on top of the fraction if we end up with a fraction at the end. Now I have k to the negative third. Notice I put an orange line underneath it. I only want you to focus on that k. K to the negative third. It has a negative exponent, which means we need to move it to the bottom. It starts on the top. We move it to the bottom. We now know we're going to have a bottom to this answer. So we have k to the third power now. Notice it was a negative. I moved it to the bottom. It's now a positive. And now we go to where the power rule really takes place. Power rule here says that if I have an exponent above another exponent, and here I have it above 2, I have it above the 2 and the 4, I need to do what? Multiply my exponents. So I'm going to say 3 times 4, and I'm going to get m to the 12th. I'm going to say 3 times 2, and I'm going to get n to the 6th. And then I need to now focus on, I've done the blue. We're done. Green, orange, blue has all been taken care of. Last standing is this yellow, which is a negative exponent for p. And we know if we have a negative exponent, we want to move it to the top. So I need to take p to the negative 8th, move it to the top, and change it to p to the 8th. And there is your answer. There's nothing else to simplify because all of my exponents are now positives and have been shifted to where they need to be. And now me being the type of person that I am, I want this to look good. So I'm going to say negative 3 m to the 12th, n to the 6th, p to the 8th over, and I'm just going to shift that k to the 3rd to the middle. Just because I want it to look good. And there we have our result. So what were we using in all these problems? Here you are focusing on what the power rule really is. Hopefully you've already watched my videos on what negative exponents do. If they're a negative exponent, they got to go to the bottom. So negative here on the bottom, move to the top. Negative on the top, move to the bottom. And so we're using negative exponents and the power rule when solving both of these. Again, if you can break it into small parts and focus one piece at a time, your life will be 1,000 times easier. I can promise that. Hopefully this makes sense to you. If you have any questions or things that weren't making sense in this video, shoot it into the comments. I'll try and get back to you and explain what it is that you're confused on. And hopefully that this helps you prepare for an upcoming test. Good luck.